Hello, this is Roberto and this is the HVAC is my channel. Today we're going to be talking about duct loads in the attic. All right, so let's get into it. So thank you so much for the comments because this came up because one of the subscribers was asking what happens if we have a vaulted ceiling or a different type of ceiling. What happens with the heat loads? How does this affect my sizing of the unit? So in here what we need to focus is number one, we need to see where the ducts are running. For example, this is one of the examples that I did, a video I made before. This is a one-story house, okay? So it's a single home. And as you can see, this is my system and all the attics are running in the attic, okay? So we gotta be careful with that because anytime you run your ducts in the attic, you have to have proper insulation, you have to seal very well your ducts, and you gotta make sure that they're installed properly. So I would say some kind of commissioning or verification, testing and everything would be very well recommended for these houses because let me be honest, so depending on the price of the house, sometimes the home builders wouldn't put so much attention on these duct leakages, but if the house is sometimes is more expensive, so they try to do sometimes a better job. So depends how well they're installed again. Okay, so now we need to see in here what happens. So in order to see that loss, we have to check on the duct load settings, okay? So if we go here, it says the owner's bedroom, okay? So let's go there. If you click there, we right click and then we have this window. In this property sheet, you have the duct heat loss factor in percentage, duct sensible gain factor in percentage, and duct latent gain, not a percentage BTUs hour, right? Okay, so in here it's saying like 31.5%, 55.5%, and 189%. Okay, so that's what you have to look for. Okay, how are you gonna go there? So remember, these three factors are very important. So you need to input the properties. You need to select the properties to obtain this. Okay. All right, so let's go for the first one. So we're going to go to the duct heat loss factor. So if we double click in here, you're going to be able to see this window. All right, so in here what do we have? So we have duct loads for the owner's bedroom. Okay, why is the owner's bedroom? Because that's the room that we already selected, right? Okay, so in here, number one, you have this. On the left side you have supply. On the right side, we have return, right? So let's start with the supply side. On the supply side, what do you have? You have supply, and then you have the configuration, you have the location, you have the ceiling, leakage, and heating, discharge, air temperature, ambient temperature, surface area, okay? Okay. So let's start for the first one. So supply, location. You're going to be able to see in here different options. Where are your ducts located? So conditioned space? Yes, that would be the best. Try to have your design in conditioned space, right? Okay, vented attic, that's the terrible idea. So usually if you have it in the attic, it's always going to be vented, okay? So that's why we have it as vented, but a better idea sometimes, if you have an encapsulated attic, you make this attic conditioned kind of thing, so that would be better. So as of now, we have it as a vented attic. That's what is more common. So this is crawl space in the basement, in the garage, and the slab wall. So in this case, we're talking about attic. So you're either going to have a vented attic, or encapsulated attic. So let's go for the vented attic, the most classic. Okay, so now we have roof material and the roof color. Okay, so that's going to affect also on the heat loss or heat load, I mean. Okay, so what's the roof material? Okay, so now again, so if you have like the vaulted ceiling or it's a big ceiling, or so mainly all the heat loss or heat loads depends on these properties, depends how well insulated it is, depends on the R value of your insulation, depends on the surface area of your ductwork. Mostly depends on that rather than the type of the ceiling, right? Okay. All right. So in this case, we're going to go for the roof material. It's going to be asphalt shingle, tar gravel, and then metal or membrane, wood shake, tile slit, or concrete. So as you can see, you're going to be able to see if you change these percentages are going to change, right? So in here, as of now, the heat loss, sensible gain, these percentages are default of manual J. The manual J from ACA, those are default values, okay? But this is gonna depend on the type of, on the type of ceiling, not ceiling, the ceiling, see, average. And then in this case, if we have roof material, see, asphalt, shingle, tar, gravel, membrane, you're going to be able to see that changes actually. So number one, it's going to change the description actually. So if you see in here, for example, description, asphalt shingle, so you're going to have supply, vented attic, dark asphalt shingle roof. So if you got tar and gravel, it changes, right? And then membrane, it changes, wood shake, it changes. Okay, number two, asphalt shingle, you're going to be able to have, see, sensible gain, you have 55.5%. Tar and gravel, same thing, 55.5%. You're going to put like metal or membrane, same thing, 55.5%. Wood shake, oh, you have 51.8%. There you go. And tile, slate, or concrete, you have 48.1, right? Again, we're going back, see, see, that's the way it changes. So pretty much it affects on the sensible gain. Okay, what about the roof color? You have dark, light, and white. So again, it's going to affect pretty much the sensible heat gain. So dark, see, it's 55.5%, and then light, it's 51.8%. And usually, so what happens in case you have a lawsuit because the homeowner was a lawyer, and then he says like it's always is not hitting very well, and I spent like $15,000 on this new unit, and then I really need compensation. The good thing is that once you do your heat load calculation, this is a software approved by ACA, Air Conditioner Contractors of America. So it's compliant with code, it's compliant with that method of duct sizing. So you're covered a little bit. So that's why it's very important to have this kind of backup. Okay, so in here you're gonna have dark, it's 55.5%, and then light. Okay, there we go. We're gonna leave it as dark because I'm leaving this as a default because we wanna account for the worst case scenario, okay? All right, let's go for the next one. We have configuration. And in the configuration, we have radial perimeter outlets. So what does that mean? That means that it's going to be radial. It's all going to my unit, and then perimeter outlets. These registers are going to be mainly on the perimeter. We have other options too. See, radial center of room outlets, trunk and branch perimeter outlets, trunk and branch center of room outlets. Different options. Okay. Okay. Let's go to the second part because on the return it's going to be the same. You can adjust your settings. Okay, so for the ceiling, we have different types. You can have your ceiling as partial, as unsealed, partial, average, notable, extreme. In manual J or in the program, you have it as average. So this affects the CFM of leakage. So as you can see in here, leakage heat is 46.8 CFM, cool is 46.8 CFM. Let's put like unsealed. Oh, see, the leakage is 136 CFM. And then what happens if you put partial? Oh, now it is better actually. So if it's better, it says 93.6. Okay, we're gonna go average, and then average it says 46. Okay, if you wanna go more, if you wanna go deeper on energy efficiency, you have notable, see, 35, and the best, extreme, 23. So that's the best, right? So as overall, again, do it as extreme, it's okay, but it's better to be on the safe side. You try to be conservative, so let's try to do average. There you go. So you're being conservative, but not too conservative, right? See, not too conservative to have like an 81%. So let's do average as a default. And also, what is the insulation value of these flex ducts in the attic? That's also very important. In here it says insulation R6. I wouldn't think that would be a good idea because in the attic we gotta be careful. Okay, but who says that? You know, what we can do is we're gonna check on the code, energy conservation code, depending on the location. What is the minimum required per location? For example, in New York City it might be different, or in Florida or in Miami might be different. But I wouldn't put a 6, I would put minimum an 8. Even you can go upper, which would be better, right? Especially if your ducts are located in the attic. Okay. All right, we're gonna go back to this and check on code. So that's also a very good practice. So we're gonna go to the heating discharge temperature. Air temperature is 100, see, 100 degrees Fahrenheit. And we must, what is it? So, no, we're gonna go back again. There we go. Okay, so we have it here. So heating discharge temperature 100, and then ambient temperature. You can always change this. For example, if there is like a home builder, they wanna change these parameters, they will let you know. Absolutely. Some companies, they have their own parameters. So surface area is the amount of ductwork. See, the surface of the ductwork, you have the length, you have the diameter, and you can add them all up. You have the total surface area of the ducts. All right. Okay, so on the other side for the return, you have the same. Let's continue on the system leakage type. How are you doing this leakage type? This is manual J, or the strategy could be %. See, then you're gonna have to add these percentages. You can have this based on the CFM only, and then you can have based on energy star. It's already giving you those parameters, those values, as you can see in here. See, it's less, actually it's less, and it's very more efficient. But again, just to be safe, always the homeowner is not going to complain actually if the system is cooling too much. It's very cold. They always complain if it's not cooling. All right, but you don't want to oversize at the same time. If you need a house with a 2.5 ton unit, you don't want to put just, let's be safe, let's put a 5 ton unit, right? So because you would have short cycling and more issues, right? Okay, so that's why we're just going to put in default and then be conservative like this. All right. Okay, so what we're going to do now is we're going to put in okay, but let me tell you, where does this go? See, sensible gain, heat loss, and latent gain. Okay, we're gonna hit an OK, and then we go here. So in here in your worksheet, for example, if we're talking about this owner's bedroom, you go to the worksheet. In the worksheet, you're gonna put owner's bedroom right here. Oh, let's do it a little bit more. Owner's bedroom right here, right? So on the owner's bedroom, we go down, and it says it is not the load of the envelope infiltration room. No, internal, no, it is this duct loads. Duct loads in here indicates 31% and 56%. And remember, this is based on the leakage, right? So this is based, you can always double click on, it doesn't allow me to click. What about this? It doesn't allow me to click. Okay, no problem. So you can always check in here. So what was it right here? So this is depending on this configuration in here, vented attic, and then as we were explaining before, leakage type, and then the ceiling type, right? Okay, so just as a, yeah, just reminded that. Okay, so see, in here you have your BTUs per hour for heating and cooling. So that's the load, and that's why it increases the load so much in here. Okay, all right, so that's regarding to duct leakage. Okay, so now let's analyze this a little bit better. Now we have to see the code, right? We always have to be protected. We always have to be informed as professional contractors, professional engineers. We need to be safe. So let's analyze on code. We're gonna take into account 2 examples. For example, what happens in Florida? In Florida, by code, because that's the fancy word, right? Code, they always like saying PIR code, the code says this, and everything is code. Apparently it sounds good. So if we want to be protected by code, what we do is, let's go to Google. All right, so we're gonna go to Google in here. Let's go here. If Google is there, let's try to use it, right? Okay, so in Google, we're gonna choose state number 1 is Florida. There we go. So we're gonna put up codes, Florida. There you go. So if we're gonna go up codes, Florida, this is Florida building codes, FBC, right? So if we're gonna put Florida building codes, we have all the codes that related to this state, right? So we have building, residential, existing building, plumbing, everything. So whenever you're talking about insulation in ducts, you go to the energy conservation code. So in energy conservation code, we have in here FBC, Florida building codes, energy conservation code 2023. Okay, interesting. It's like more updated. Okay, so we're gonna go there. So we clicked in here, energy conservation code. From the energy conservation code, we have, don't forget, we have commercial provisions, which is in here, and we have residential provisions, which are down here. Oh, I don't see it. Where is it? Where is the residential provisions? Let's see. There we go. Chapter 1, Chapter 2. It says RE, residential. It says CE, commercial, right? Okay, let's go to the residential first. In residential, the code is, let's go to number 4. Chapter 4 indicates residential energy efficiency. If you click in there, in residential energy efficiency, you have sections, right? So what is like our section or chapter? In here, we have to go to 403. R403 systems, right? So R403 systems, we're gonna go here, section 403 systems. Now we have to go to number 3, R403, another section, we have ducts. And then from ducts, we have insulation. All right, there we go. Let's check what they say for insulation. Insulation, you have, so in order to comply with energy performance with International Energy Conservation Code or the local code, okay, you have always or most of the times 2 options: to comply by method of prescriptive or performance. Okay, so to make it simple, we're gonna make it as prescriptive. And in prescriptive, it says, let's read this. Supply, oh, I'm gonna make this a little bit bigger. There we go. All right. So code. So if they have any issues with the insulation in the duct, you can always refer to code section R403.3.2 insulation prescriptive method. It says supply and return ducts in attics, right? That's what we're talking about. It doesn't say about the type of ceiling, roof. It doesn't say that, right? So we need to comply with that. Supply and return ducts in attics shall be insulated to a minimum of R8. There we go. So in that case, if you have an R6 in the attic, then you are not complying with code, right? So R6, but in here it says where 3 inches in diameter and greater. So if it's more than 3 inches, you need to have R3. If it's less than 3 inches, if your duct is less than 3 inches, you can have R6. That's all it's saying. But honestly, I haven't seen like 3 inches. It's very small. So I usually minimum I put diameter of 4 minimum, and then we put R8 minimum, right? Okay, that's what happens. And then there is there is more information in here, like indicates if it's not located in the attic, your supply, if it's in a conditioned space, no, it says if it's not in the attic, supply and return ducts in other portions of the building, which means not in the attic, shall be insulated to R6. Okay, we're fine with R6. For example, if my ducts are running in the garage, R6, all right. Okay, so, or where 3 inches in diameter or greater, or R4.2, right, where less than 3 inches in diameter. Okay, so there we go. So any other place than the attic, we can have R6, but remember, this is the minimum. If you want to achieve energy goals or you want to make the customer happy, but unfortunately that goes with a cost, right? Whenever you're trying to save energy, it comes with the price tag, right? It increases the property value, or I mean the price of the property, right? Okay, so it says a minimum of R6 were 3 inches, okay, or 4.2 if it's less than 3 inches, 4.2. So that's in places that are not in the attic. Or if the ducts are buried beneath the building, no insulation required in here, even it says, right? Okay, so let's go back to the point. It says for supply and return in the attic are 8. There we go. We're protected by code. We're gonna go check very quickly on the what is the commercial code. If in the international energy compliance code, we're gonna go to the commercial section. Where is it? Chapter number 4. It's this residential CE. Chapter number 4, commercial energy efficiency, and then we're gonna go to 403, which is building mechanical systems, and then we're gonna go section. This is section 403, and then we're gonna go to number 2. This is what is it called? Provisions applicable to all mechanical systems mandatory. And then we're gonna go to section in here, finally number 9. See, section 403.2.9, duct and plenum insulation. Duct, and you might be wondering, but Roberto, how do you know these sections by memory? I don't know it by memory. I just Google it. I just Google in here. It says in Florida, what is the minimum insulation value? And I do dig and dig and dig more. And then in some articles, I see that the section of the code. That's all we need. We need this section. C403.2.1, duct and plenum insulation, construction and ceiling mandatory. Okay, so we're going to go here. And it's very nice and easy in here. It says minimum duct insulation are values for heating and cooling and return ducts. It says supply return. Exterior of the building are 6. So all of them are 6 minimum, but that's in commercial. We're not talking about attic, right? So as you can see, commercial and residential, they have a kind of different kind of aspect. Okay, so now we're going to go very quickly because this video is becoming longer. So we're going to go to, what is it called? We're going to go to codes, but this is going to be for New York State, okay? New York State. So in New York State, and why am I doing this in, so actually, I'm just going to do it in Google. New York codes. So why am I doing this in those two different places? The reason is those are different climate zones, right? So if we put climate zones in the USA, so we have the mapping here, right? So if we have the map right here, so this is based on the International Energy Conservation Code. See, it's gonna make it bigger. So New York is located in here. See, all this area right here. So it's almost all the way above. See, but whereas Florida is located down here. So that's why I'm choosing these two examples, just to make the two different locations. Okay, so New York State, we're gonna go again for the residential code. So New York State, we're gonna go here for the energy conservation code, and then energy conservation code, we're gonna go for residential. In residential, we're gonna go for the same chapter 4. In chapter 4 section 403 systems. See, section 403 systems, and then the same 3, and then 1. There we go. So insulation, same thing. Fortunately, it's the same thing. See, no less than R8 for supply and return if they are located in the attic. In every other space, you can have it as R6. The same thing, right? Okay, and then the ceiling, of course, is mandatory. Ceiling is very important. Actually, you have to use mastic because otherwise you have a lot of leakage. Again, it doesn't matter if it's insulated well, because if you have every single place where you have a joint, if you don't put mastic or you don't seal that duct, you're gonna have so much leakage. So it's not a good idea. You have to do sealing and you have to then insulate, right? Okay, so that's the same. Okay, so what about the commercial code? In commercial, actually, is different. It's a different section. That's very interesting, right? Every state is different. And then if you are in another country, you can take this as a reference. This has the International Energy Conservation Code has a lot of information, and you can always refer to your local codes. What do they say in Dubai? What do they say in India? What do they say in Australia, in Nigeria? Please put in the comments what is the insulation values for those countries. That would be great if you share. Okay, but take it as a reference, and then we're gonna go here and then let's go here for the commercial. In commercial, it's gonna be 403. See, section 403. 403.11. In this case, it's 403.11 in New York City. That's very interesting, right? Okay, 403, and then we go here 11, and then 1. See 403.11. Isn't it interesting? It's a different section. It's a different completely section rather than Florida. In Florida it's 403.29. In here it's 403.11.1, right? Okay, so supply and run of the tax, it's okay. In here is indicating the same, okay? So in here for commercial is pretty much the same. R6 insulation were located in an unconditioned space, and also were located outside of the building no less than R8. So if it's outside on the building, let's say on the roof or something, it has to be R8 minimum. But if it's plants will be insulated with no less, or R6 where it's in unconditioned spaces. Okay, again, supply and return air ducts and plenums shall be insulated. All right, of course it's going to be insulated no less than R6. Okay, but where is it located? They are located in unconditioned spaces. Okay, so if it's an unconditioned space, yeah, there is places in a building like that. Okay, okay, so where located, for example, let's put like a loading dock, a mechanical room sometimes. Okay, so we're located outside of the building. Let's talk about the roof, for example. No less than R8. There we go. All right. Alrighty, so that's the code analysis, and that's what I was trying to bring to in these tips and tricks. Okay, and then the ceiling is also very important. You have to do some tests with that, but we're gonna be seeing that in other videos. All right, so leave any comment, and then any advice, any suggestion for the channel is very appreciated. Okay, I'll see you in the next video.